Hello everyone, this is chapter 2 homework. I will go ahead and help you with some of these questions that involve calculations and some explanation. So the first one is asking kaolinite, a clay mineral with the formula given, and analysis shows that 14.35 gram of kaolinite contains 8.009 gram of oxygen. Calculate the mass percent of oxygen in kaolinite. Very straightforward question. The mass percent can be calculated. Percentage. The amount of oxygen given is 8.009 grams, and then the mass of the whole compound is 14.35 grams. So you divide 8.009 grams by 14.35 and you multiply by 100. This will give you the mass percent of oxygen. Okay, that's how you would do that problem. And then number 2, you can find out who is credited with measuring the charge of the electron. And then the third one also you can do, who discovered the atomic nucleus. Number 4 also you guys can do, conceptual one. Number 5 also you can do. Number 6, which of the following symbols does not represent an element? So where do we find the elements? We find the elements in the periodic table. HF, O2, CS, Xe, CO. So now which one is the one that is not an element? Which is the first one, hydrogen fluoride. B, oxygen, normally it exists as a diatomic molecule, so that's an element. C is a cesium, D is xenon, which is a noble gas, and E is a transition metal, cobalt. So the correct answer for that is hydrogen fluoride, right? Number 7, again that's an easy one too. Consider the isotope bromine given as 81, bromine 8135, right? So you are given bromine 8135. What is 35? 35 is the atomic number. In other words, that's the number of protons, right? 35, and 81 is the mass number. So how do we get the mass number? Mass number is the sum of the number of protons plus the number of neutrons. So you want to find out atomic number, neutron number, and then the mass number. So the atomic number is this guy right there, 35, or the other, in other words, number of protons. And then the number of neutrons. How do we find the neutrons? You get this number, which is the mass number, 81, and you subtract 35. That will give you the number of neutrons, because 35 is the number of protons. And then the mass number is this number right here, 81. Okay, so you can choose the correct answer. And then the number 8, atoms X, Y, Z and R have the following nuclear compositions. So you can see X, Y, Z, R, you are given the atomic numbers, and also you are given the mass numbers, your superscript. So what are the isotopes? Isotopes have the same number of protons, but they have differing number of neutrons. And when you are written the symbol like this, always the bottom number or the subscript is going to be your number of protons. So you will find the one that would have same number of atomic number or the number of protons. So which two has the same number of protons? So the first one is 186, 183, 186, 185. So which two do you think are going to be the isotopes? So 186 over here has the same number of protons as this one, 186. Right, the bottom number is the number of protons, and then they both have differing number of neutrons, because the number of neutrons would be this, the green circle, which is the mass number. When you subtract the number of protons, they would have two different number of neutrons. The difference would be 2 neutrons because one is 410, the other one 412. So that's the mass number. So subtracting your number of protons, 186, will give you the number of neutrons. So the isotopes have the same number of protons, but they have differing number of neutrons. Okay, so now you know the correct answer for that. Silicon, which make up about 25% of Earth's crust by mass, is used widely in the modern electronics industry. 3 naturally occurring isotopes, silicon 28, 29 and 30. Calculate the atomic mass of silicon. And we are also given the percent abundance. So these are the isotopes, these are the masses, and then these are the abundance. So to find out the atomic mass, we're going to take each isotope and you multiply it by the percent abundance and then you sum them up. Now if you take the first one, this one here, 27.976927, you multiply it by the percent abundance. 92.23, so the percent abundance would be 92.23. You divide it by 100. That would make it 0.9223. So you multiply this by 0.9223 and you get the answer. And then you take the other number to 28.976495 times 4.67%, meaning 4.67 divided by 100, 0.0467, and you get the answer for that. And then 29.973770 times 3.10%. 3.10% is 0.0310. You get the answer. So once you get these three answers, you sum them up. You take the sum of the three answers once you are done with your multiplications and you get the correct answer. Okay, that's how you do that problem. Number 10, also you guys can do. Which of the following is a non-metal? Remember in the periodic table we talked about that towards the right side you would see a zigzag line starting from boron. Okay, and then you will see, so the metals would be in this side and then the non-metals would be on this side of the periodic table. Non-metals, right? Starting boron is right there and then you have aluminum right there, and then also right below boron would be the aluminum. Got the wrong place for that. Boron, and then you will have, okay, aluminum here, and then you have silicon right there, and then germanium like that. You see this line starting from boron, it would be a bold line that separates the metals from the non-metals. Left side would be the metals, right side would be the non-metal, and then along the line you will see some metalloids that they have both metal character as well as non-metal character. So you can find out in the periodic table where is sodium located. Sodium is in group 1, right? So that's a metal. And then the mercury also, it's a transition metal. You will find the mercury also in the left side of the zigzag line. And then the bismuth is going to be in group, which group is it? Bismuth. Bismuth is also a metal that you will see that falls in the left side of the zigzag line, the bold zigzag line for the bismuth. And then the bromine, you will see bromine is in group 7. Group 7, which is the halogens that you will find fluorine, chlorine, bromine, atomic number 35. That's going to be the one that is non-metal. And then which is the following is a metalloid. Metalloid is are the elements, metalloids are the elements that you would find along the zigzag line. So bromine is in the non-metal side, and then the germanium if you find germanium, atomic number 32. So find where is germanium. And iridium being 77, it is again in the left side of the zigzag line. Carbon again, carbon, excuse me, atomic number 6 on the right side, and then the sulfur again in the right side. Okay, so find out which one falls along the zigzag line, this zigzag line, so then you can see which one is the metalloid. And what is the row of a periodic table called? Is it the period, group, subshell, isotope, mixture, family? You guys can answer that too. Which of the following compounds is ionic? Ionic compounds. So how do we form ionic compounds? So ionic compounds are formed between metals and non-metal. Okay, that's how the ionic compounds are being formed. And they share electrons when they form, not share, they transfer electrons when they form ionic compounds. So that happen between metals and non-metals. Metal will lose an electron and non-metal will gain that electron. And then the covalent compounds normally form by sharing electrons. And the covalent compounds are formed between non-metals. Okay. So which of the following compounds is ionic? So carbon disulfide. And also when you are naming ionic compounds, remember we don't say di, mono, tri like that. We do not use those prefixes. So the name of the first one is carbon disulfide. Carbon is a nonmetal, sulfur is a nonmetal, so that's a covalent compound. And then you locate where is PF3. Phosphorus is again in the right side of the periodic table to the zigzag line, and also the fluorine. So both of them are non-metals. So they are again a covalent compound. And how do we name PF3? For the covalent compounds, we use prefixes di, tri like that. So we have only one phosphorus, and always for the first element, we don't say mono, right? So we just say phosphorus, since we have only one, and there are 3 fluorides, so we would say tri because it's a covalent compound. So for the covalent compounds we use prefixes. So the name of the PF3 is phosphorus trifluoride, which is a covalent compound. And HCl, again hydrogen is the number 1, having 1 atomic number or 1 proton, atomic number being 1. It is in the left side of the periodic table, but that is a non-metal. So hydrogen is a non-metal, chlorine is a non-metal, so that's again a covalent compound, hydrogen chloride. And SO2, again SO2, sulfur is a non-metal, oxygen is a non-metal, so that is also a covalent compound. And how do we name that? Since for the covalent compounds we have to use the prefixes indicating how many atoms, but for the first one we don't say mono, so the name of SO2 would be sulfur dioxide, and it is a covalent compound. And then when you look at the magnesium chloride, magnesium is metal, magnesium is a metal, and then the chloride is a non-metal, so which is an ionic compound between metals and non-metals. And for the ionic compounds we don't use prefixes. We do not call magnesium chloride as magnesium dichloride. That would be magnesium chloride. Okay, so now you know how to find whether a compound is ionic or not, and also about a little bit about the naming. I have explained this in my lecture video, so you can refer to that to get in more detail. After an atom has lost an electron, it becomes and has a charge. What kind of a ion you form when you lose an electron? When you lose electron, you form cations. And when you gain an electron, you form anion. And then the cations are positively charged and ions are negatively charged. So this is asking after lost an electron. Okay, so now you know the answer for that. Again, number 16 asking which one is covalent. Again, you have to see what are the two elements involved, whether they are metals or non-metal. If the compound is formed between metal and non-metal, it is ionic. Between two non-metals, that's going to be covalent. So cesium sulfide. So this one, cesium. Cesium is a metal. You find it in the first group. Sulfur is a non-metal. So that is an ionic compound. And the name for that is just cesium sulfide, since we don't use prefixes for ionic compounds. So that is ionic compound. Magnesium oxide. Magnesium is a metal. Oxygen is a non-metal. Again, that's a ionic compound. And the name is magnesium oxide. Aluminum oxide. Aluminum oxide is a metal. It is also lie along the zigzag line, so it can also be considered as a metalloid. Okay, so since it's in the metal side, normally it forms ionic compounds. Aluminum oxide. Made between metal and non-metal, and again the name is just aluminum oxide. We don't say dialuminum trioxide because it's an ionic compound. Okay, and then the calcium is a metal, chloride is a non-metal. That's again ionic compound between metals and non-metal, and then the name would be just calcium chloride. Okay, so we don't use prefixes. And then the PCl3, phosphorus is a non-metal, chloride is a non-metal. So now we found our covalent compound. Between non-metals, you form the covalent compounds by sharing electrons. So what would be the name of this one? Now for the covalent compounds, we use the prefixes. For the first one, we don't call mono. If you have just one, that is just the phosphorus. And then since there are 3 chlorides, the name would be phosphorus trichloride. Okay, that is the answer for that. And then the 17, sodium oxide combined violently with water, which is the bonding formula and the bonding. Now the sodium oxide, you first find out where the sodium is located. Sodium is in the group 1, and then group 1 elements normally form +1 charge. And then the oxide is in group 6, which is a non-metal, right? So non-metals would like to gain electrons, and oxygen is in group 6. So to become an octet and resembles a noble gas configuration, oxygen would like to take 2 electrons. So oxygen normally make -2 charge, right? So we have a metal and a non-metal. So between metal and non-metal, what kind of bond do you normally form? Which is ionic bond, right? Remember we talk about ionic bond, and we need to find out the formula. So I explained this in the lecture videos also. To find the formula, you take the numerical values of the charges and then you crisscross them, because at the end we need to have a formula or a compound that is charges are balanced. So the 2 would go next to sodium, and 1 from the sodium go to next to oxygen. Normally you do not write 1, so it would be Na2O. So now there are 2 sodium atoms and 1 oxygen atom. Each sodium has a charge of +1 and there are 2, so that makes it +2 charge. The positives are 2 and oxygen is -2. So now the charges are balanced and the molecule, the compound is neutral, +2 and -2. So how to find the formula is always, you find out what are their charges. The same thing for your polyatomic ion complexes too. And then you crisscross the numerical values of the charges. That will give you the charged balance correct formula. So then you know the formula is Na2O, and since it's between metal and a non-metal, the compound is ionic compound. Okay. Number 18, MgF2. What is its name? Magnesium. Again you find out where magnesium located in the periodic table. Magnesium is in group 2. So the group 2 ions normally form plus 2 charges by losing 2 electrons, positive charges, cations. And then the fluoride is in group 7 in your periodic table. So the group 7 elements, to resemble noble gas configuration, valence electron configuration, which is 8, it would like to gain 1 electron. So the fluoride form -1 charge, right? So that's how you get the MgF2. So 2 goes here and 1 goes there. So that would be MgF2. And this is, since magnesium is a metal, fluoride is a non-metal, this is an ionic compound, right? And for the ionic compound, when we are naming, we do not write the prefixes di, mono, right? So this is just magnesium fluoride, not magnesium difluoride, because it's an ionic compound. You don't call magnesium 2 fluoride because magnesium is a main group element. Your main groups are group 1, which starting as sodium, and then the group 2 magnesium, which is again a main group, and then you jump to the other side starting 5, atomic number 5, which is boron. So boron to neon, so that is our main group elements. And then in between you will see from beryllium to boron, so those elements are your transition elements. If an element or a metal involve transition element, some of these transition elements can have more than one oxidation number. Then we will have to say in parentheses what is the oxidation number if the element is a transition metal. But magnesium is a main group element, so you don't have to say magnesium 2 fluoride, you just say magnesium fluoride. Okay. Number 19, barium oxide. What is its name? Again, what you need to do is you locate barium. Barium is in group 2, which is a main group element. And then you go to oxygen. Oxygen is a non-metal. So this is a metal and a non-metal. Barium is a metal, oxygen is a non-metal. So it forms ionic compound, right? And then once you figure out whether it is ionic or a covalent compound, then you refer to the rules for the naming of the ionic and the covalent compounds. And for the ionic compounds, you do not use the prefixes. And for the covalent compounds, you would use that. So this one is just the barium oxide. Okay, barium oxide, not barium monoxide, since it's not a covalent compound. It's not a barium peroxide either. So the correct answer is barium oxide. Not barium 2 oxide, because barium is not a transition element. It is a main group element. Now the name of this one, cobalt Cl2, COCl2. You locate where the cobalt in your periodic table. You find cobalt atomic number 27. Is it a metal or a non-metal? Cobalt is a metal because you find it in the left side of the periodic table from that zigzag line. But the cobalt is not in the main group element. It's a transition element. So for cobalt, we need to figure out what is its oxidation number or the charge, and we have to put that in our name. Normally, so since this is ionic compound, cobalt is a metal and then the chloride is a non-metal. So it is an ionic compound, right? Ionic compound. And then you see whether the metal going to be a main group or a transition element. It's a transition element. So we need to find out what is the charge of the cobalt. So cobalt chloride is COCl2. Excuse me. To find the charge, what you need to do is, once you are given the formula, just like if you know the charge, you can find out the formula by crisscrossing the numerical values of the charges. We can crisscross here like that. Cobalt, there is 2, that 2 goes next to the cobalt as a superscript, and then you don't have anything here. If you don't have anything, that is 1. So 1 goes there. So the first element always going to be positive. So 2 goes here. Metals are only always making +2. So cobalt would be +2 charge. And then the chloride, so the second element would be your anion, -1. 1 goes there. So from back calculating using the subscripts, you can find out there are relevant superscripts which gives you the charge of the element. So cobalt is +2. So then the chloride is -1. So that tells you cobalt is +2. So then your name of the compound going to be cobalt. Since it's a transition element, you have to say what is the charge. You put it in parentheses, numerical value, and then the chloride. Chloride. So cobalt 2 chloride. Not copper. CO represent cobalt. So there would be cobalt 2 chloride. Okay. In the ionic complex M2X3, the likely charge on X, same thing. So you are given M2X3. So these are the number of atoms of each kind. So if you want to find out their charges, just like I mentioned earlier, so you can crisscross these back here. 3 goes there. 2 goes as a superscript next to X. So always we write the metal first, and metals are forming cations or the positive charge. So the 3 has to be plus, and then the X you put 2 next to it, and then the second element is always negative, right? So it's asking charge on X. X is going to be then -2, right? The charge of the X is -2. And then the charge of the metal would be then +3. So that also balances our charges. So there are 2 metals. So 2 times +3 is +6. And for the X, there are 3 X. And then 3 times -2 is -6. So that balances our charges for the 2 elements, and we have a neutral compound. Okay. Which of the following is a polyatomic cation? Polyatomic cation. Okay. Now you can refer to the cation chart given in our lecture slides, as well as the handouts posted on Blackboard. Okay, remember I showed you there are some useful handouts for the exams on Blackboard site along with the periodic table, and on the page 6 of that you will see some polyatomic ions. Also you have some polyatomic ions I posted as useful handouts for exams on the Blackboard. Okay, so we are looking at cation. Cation is something positive and anion is negative, and cation, so you want to find out the cation mean positive. So nitrate, you will look up nitrate, and nitrate is NO3 minus. Okay, and then the hydronium is H3O plus. When the water molecule grab a proton, it become hydronium. And then the chromate would be CrO4 -2. Chromate, that's again an anion. And then the potassium is just K, potassium, and permanganate is potassium permanganate MnO4 -2. So you see which one is the positive charge or a cation, hydronium ion. There are very few cations. Hydronium is one, and then you will see ammonium ion is another one, and then I think mercury also has a positive charge, one of the cations. So you can refer to that in the handout. Okay, so the correct answer for that would be hydronium. Okay, which of the following combinations of names and formula of ions is incorrect? incorrect one. So cyanide is Cn minus. So sulfate, perchlorate, barium, bicarbonate. Again, you can refer to the chart on blackboard and find out which one is the correct one or the wrong one, incorrect one. So the chart that I'm referring to is, let me show you where to find that chart. Okay, over here you go to handouts given in exams, you click that, and then here periodic table and handouts. So this is one handout. Okay, so this is a periodic table, and you go down. So chemistry data handout, you go to page 6. So page 6 have some polyatomic ions, so you can refer to this one. So sulfate, so you find what is sulfate. You see sulfate is SO4 2 minus. Minus 2 is overlapped, but you just look at the column. So the first column is all the anions. -1, second one -2, -3, and so on. So you can refer to this chart. Sulfate is -2, right? So -2 is kind of overlap with the 2. So for 2 minus. Okay, so this is one place that you can look up the polyatomic ions, and another place that you can use is you use this useful info, download linked file over here. So you can see all the prefixes table here, and also the equivalence of the quantities, and then the temperature changes, how to convert, and also polyatomic ions. We also have sulfate here, SO4 2 minus right there. Okay, so refer to these ones, and let's go back to our homework. Okay, okay, so with that you can find out which one is the incorrect one, referring to those tables. And then which of the following combinations of names and formula of ions is incorrect. Again, you refer to those two tables to find out what is perchlorate. Is it ClO3 minus or ClO4 minus, ClO2, ClO? So find out which is incorrect one. Cyanide, thiosulfate, ammonium sulfide. Okay, now I showed you where to find the answer. You can do that. And then 25. Name of MnSO4. Now the manganese, where's my pen? What happened to the pen? Where did you go? So manganese, it's asking what's its name. You find out where manganese is located in your periodic table. It's not magnesium. Mn is manganese. So Mn is atomic number 25, which is a transition element. So they can have more than one oxidation state. So when you're writing the name, you need to find out whether you need to put the Roman numeral in parentheses or not. Let me see if I can get my pen back. Homework PDF. We download it again. right there now. That's good. Okay, MnSO4. So we need to figure out, so this is an ionic compound because manganese is a metal and sulfate, the two things that put together is manganese and sulfate. Sulfate you can consider as a polyatomic ion. So manganese is going to be your cation and sulfate going to be your anion. And we don't know the oxidation number for manganese. So how do we find it out? We find it out from the known one. Now the sulfate, if you look up the chart that I showed you, sulfate has a charge of -2. Okay, and our formula is given as MnSO4, meaning the ratio for manganese to sulfate is 1:1. In ionic compound, so this is ionic compound between manganese ion and sulfate ion. In ionic compounds, we normally do not write Mn2SO4 2. So if you have the same coefficient, you would cancel it and then you write it as MnSO4, right? So sulfate we know from the polyatomic ion chart, sulfate is -2. So then the manganese also has to be charge +2. So that is how you can balance the charges 1:1 ratio. 2 and 2 get cancelled. So manganese is +2 and sulfate -2. So 2 goes there, 2 goes there. That will make it Mn2SO42 and they get cancelled. So your formula is therefore MnSO4. So by figuring out what is the charge of the anion, you can figure out the charge of the cation. So because of that, manganese is +2. Since it's a transition elements, you put manganese 2, and then since SO4 is sulfate, you write sulfate, manganese 2 sulfate. That's the name of that. Okay, and then the next one, the substance KClO3. What is its name? Okay, so KClO3, potassium and then ClO3. So the first element is potassium, which is a main group element. And then you have ClO3. So the two ions, one is potassium, the other one is ClO3. Okay, so you find out that potassium is in group 1, it normally forms +1 charge. You refer to the table chart polyatomic ions and you locate what is ClO3. So you will see that the ClO3 stands for chlorate and it has a charge of -1. So you are given this as KClO3. So then the name is going to be potassium and you figure out what is the name. ClO3 is going to be chlorate, but refer to the chart and then you write potassium chlorate. It's not potassium chloride because you will see what are the formulas for chloride. And then chlorate, you see what is the formula for chlorate, chloride, and then the chlorate. You do not need to put the parentheses because it's a main group element. Only transition elements you would put the parentheses. Okay, so find out what is ClO3. So you know where to find out. I showed it to you. You see here, if you ClO3, you see here ClO3 chlorate. So you figure out like that. And then the next one, what is the name of the acid formed when HBr gas is dissolved in water? you take hydrogen bromide. So the name of this compound is by itself, HBr is a hydrogen bromide. Okay, but when it is dissolved in water, it becomes an acid. So then it would become hydrobromic acid. If you have HCl by itself, it would be hydrogen chloride. Okay, hydrogen chloride, covalent compound, and when you dissolve in water, it becomes hydrochloric acid. Remember, we talk about in the lecture. Same thing with the HBr gas. HBr by itself is hydrogen bromide. Once it dissolves in water, it becomes a gas and become hydrobromic acid. Okay, for H we say hydro and then the bromic acid. And then the next one, what is the name of PCl3? Again, the PCl3, you figure out whether it is a ionic compound or a covalent compound. And then the phosphorus is a non-metal, chloride is a non-metal. So between the non-metal, you form covalent compound, and then we use the prefixes. So for the first element, having one element, you don't say mono. So because of that, you would just say phosphorus, and there are 3 chlorides. That would be phosphorus trichloride. Okay. This one over here, P4S10. Again, the same concept. Phosphorus is a non-metal, sulfur is a non-metal, so it forms covalent compound, and then you would have to say the name with the prefixes. And there are 4 phosphorus atoms, so then we have to represent that by saying tetraphosphorus. And then the sulfur, there are 10 sulfur, and it would end as sulfide, so it would be tetraphosphorus decasulfide. Sulfur by itself, when it becomes an ion, that's sulfide. So for tetraphosphorus decasulfide. Okay. And then the next one, ammonium sulfate. You have to calculate its molar mass or the molecular mass. How do you calculate the molecular mass? Normally, you take the numbers from the periodic table. So this one is NH4 SO4. So you figure out how many elements of each kind. So there are 2 nitrogens. So there are 2 nitrogens because these 2 outside the parentheses represent for nitrogen and hydrogen both. So there are 2 nitrogens, 4 times 2, 8 hydrogens, 1 sulfur and 4 oxygens. And then you find out what is the atomic number for the nitrogen from the periodic table, 14.0067. So you take up to 4 significant figures when you are taking masses from the periodic table. So 14.01. And then the hydrogen, there are 8 times 1.008. And then the sulfur is 1, sulfur is 32, 32.065, 32.06. And then the 4 oxygens, 4 times, oxygen is 15.99, 15.99, you can 15.99 or 16. And then you add those up. Okay, however many number of atoms, you multiply it by its atomic masses, and then you add it up to give you the molar mass or the molecular mass. Okay, that one, the formula is given. And then the next one, you are given the name, and then you need to figure out what is the name going to be. Iodine pentafluoride. Iodine. So iodine is iodine is a non-metal, fluoride is a non-metal, so it's a covalent compound. It just say iodine, 1 iodine, 1. Right? If it is 2, it would say diiodine, 1 iodine. Pentafluoride means 5 fluorides, IF5. Molecular mass. You find the molar mass of iodine from the periodic table, I think 126.90. And then the fluoride, there are 5 fluorides. So 5 times fluoride is 18.998, so 19. And then you add these sums together. Will give you the molecular mass of iodine pentafluoride. And then determine the molecular mass of iron 3 bromide hexahydrate. Okay. Now you need to know how to write the formula in order for you to find out the mass. So this one, iron 2 bromide hexahydrate. Iron, the formula for iron, it's not the formula. So the element is Fe. And it says iron 3, meaning charge of that iron is plus 3. And then the bromide, Br. Okay, iron 3. Iron is given the charge in parentheses because it's a transition element. So we want to represent what is the charge of the iron. So iron is given as plus 3 charge. And then the bromide. We know bromide. Bromide is in group 7. Group 7 elements normally makes -1 charge by gaining an electron. So bromide will form -1 charge. So we need to figure out what would be the formula. So then we know how to calculate the molar mass. Once you figure out your charges, then you crisscross the numerical value of the charges. 3 goes next to bromide and then the 1 goes next to iron. That will give you Fe1 Br3, and normally you don't write 1. So FeBr3 is the formula for iron bromide. And says hexahydrate. Hexa means how many? Hexa means 6. 6 hydrate. Hydrate means H2O. There are 6 water molecules attached to iron 3 bromide. Okay, so FeBr3.6 water molecules. And now you need to find out what is the molar mass of this one. Molecular mass. Again, there is 1 fluoride. So you find the mass of the fluoride. 3 bromide, 3 times bromide. Figure out from the periodic table atomic mass of bromide. And then the 6 water. So in 6 water molecule, there are 2 times 6, 12 hydrogens. So 12 hydrogens. So 12 times the molar mass of hydrogen. And there are 6 water molecules, means 6 oxygen. Right? So then you would write 6 oxygen, meaning 6 times the molar mass of oxygen. So iron, you can refer to your periodic table. 56 something for iron, I believe. Iron 55.85. 85 grams. That's one time. And then the bromide, you find that. You can find out the hydrogen, oxygen, and then you add all these together to get the molar mass of iron 3 bromide hexahydrate. Okay? All right. I think that's all the questions we have. Okay then. I'll talk to you soon later. Bye-bye.